When we think of supervolcanoes, Yellowstone often steals the spotlight with its dramatic geysers and bubbling hot springs. But lurking beneath Earth's surface are other colossal volcanic systems, equally capable of unleashing cataclysmic eruptions. These hidden giants, often disguised as serene lakes or unassuming landscapes, remind us that our planet's fiery heart beats with immense power. Today we delve into the science of these supervolcanoes, exploring their origins, their devastating pasts, and the threats they pose in the shadows. To understand these behemoths, we must first define what makes a volcano super. A supervolcano is classified by its ability to produce an eruption with a volcanic explosivity index, or VEI, of 8, the highest on the scale. This means it ejects more than 1,000 cubic kilometers of ash, rock, and lava, dwarfing even the most infamous historical blasts like Mount Vesuvius or Krakatoa. Such events don't build towering cones. Instead, they collapse into vast depressions called calderas, which can span dozens of kilometers. These calderas often fill with water over time, masking the danger below. Supervolcanoes form in hotspots where tectonic plates interact with plumes of hot mantle rock, creating massive magma chambers that simmer for millennia before exploding. One of the most infamous hidden supervolcanoes is Lake Toba in Sumatra, Indonesia. What appears today as a tranquil, crystal-clear lake, the largest volcanic lake on Earth, is actually the remnant of an apocalyptic eruption around 74,000 years ago. This blast, rated VEI 8, spewed an estimated 2,800 cubic kilometers of material into the atmosphere. Ash layers from Toba have been found as far away as India and the Indian Ocean, blanketing vast regions in darkness. Scientists believe this event triggered a volcanic winter, dropping global temperatures by several degrees for years, possibly even a decade. The fallout may have pushed early human populations to the brink of extinction, reducing our ancestors to just a few thousand individuals, a genetic bottleneck still evident in our DNA today. Toba's caldera measures about 100 kilometers long and 30 kilometers wide, with depths plunging over 500 meters. Beneath the lake, seismic activity and gas emissions hint that the magma chamber is still active, though no imminent eruption is predicted. Toba teaches us how supervolcanoes can reshape not just landscapes, but the trajectory of life on Earth. Halfway around the world in New Zealand's North Island lies another concealed colossus, the Taupo volcanic zone. At its heart is Lake Taupo, a picturesque body of water that belies its violent origins. Taupo has been erupting for over 300,000 years, but its most catastrophic event was the Oruanui eruption about 26,500 years ago. This VEI 8 explosion ejected around 1,170 cubic kilometers of pumice and ash, creating the current caldera and altering the island's geography forever. Ash from Oruanui blanketed much of New Zealand and even reached Australia, causing widespread ecological disruption. More recently, in 232 AD, Taupo unleashed another powerful blast, the Hatepi eruption, which was one of the largest in the last 5,000 years. It sent plumes skyward, visible from as far as Rome and China, according to ancient records. Today, Taupo remains restless. It has erupted 25 times in the past 12,000 years. Geologists monitor ground deformation, where the lake bed rises and falls by centimeters annually, signaling magma movement below. Hot springs and geothermal fields around the lake harness this energy for power, but they also serve as reminders of the underlying threat. An eruption today could devastate the region, affecting agriculture, air travel, and global climate. Shifting to Europe, we find Campi Flegrei, a supervolcano nestled in the densely populated Bay of Naples, Italy. Unlike the obvious peak of nearby Vesuvius, Campi Flegrei is a sprawling caldera system, much of it submerged or hidden under urban sprawl. Its name, meaning burning fields, comes from the sulfurous fumes that rise from its fumaroles. The caldera's largest known eruption occurred about 39,000 years ago, a VEI 7 event that dispersed ash across the Mediterranean and into Eastern Europe. This blast formed the 12-kilometer-wide caldera and may have contributed to the extinction of Neanderthals by exacerbating an already harsh ice age. A smaller but significant eruption in 1538 AD created Monte Nuovo, a new hill overnight. In recent decades, Campi Flegrei has shown signs of awakening. thousands of small earthquakes, ground uplift of up to 4 meters since the 1950s, and increased hydrothermal activity. Over 500,000 people live within the caldera, making it one of the most hazardous volcanic sites on the planet. Scientists use seismic networks and satellite data to track magma buildup, but predicting an eruption remains challenging. Campi Flegrei exemplifies how supervolcanoes can hide in plain sight, integrated into human civilization. In the United States, beyond Yellowstone, there's Valley Caldera in eastern California. This 32 by 17 kilometer depression formed 760,000 years ago during the Bishop Tuff eruption, a VEI 8 cataclysm that blanketed the western U.S. in ash up to a meter thick. The event reshaped the Sierra Nevada landscape and sent debris as far as Nebraska. Today, Long Valley appears as a scenic valley with hot springs and obsidian domes, but beneath lies a massive magma reservoir. Resurgent doming, a bulge in the caldera's center, has risen about 80 centimeters since 1980, accompanied by earthquake swarms. While the system is cooling overall, with magma solidifying into crystal mush, it still poses risks of smaller phreatic explosions or hydrothermal blasts. Geologists employ ground-penetrating radar and gravity surveys to map the hidden chambers, revealing a complex plumbing system fed by mantle upwelling. Japan hosts yet another stealthy supervolcano, Valley Caldera in southern Kyushu. Formed 30,000 years ago by a VEI 7 eruption, it ejected over 400 cubic kilometers of material, creating a 20-kilometer-wide bay now partly filled by Kagoshima Bay. At its edge rises Sakurajima, one of Japan's most active volcanoes, which has been erupting almost continuously since 1955. Sakurajima's frequent blasts are vents for the underlying Era system, releasing pressure but hinting at deeper unrest. Historical eruptions, like the 1914 event, buried villages in ash and connected the island to the mainland. Monitoring shows inflation-deflation cycles, suggesting magma recharge. Era's proximity to cities underscores the need for vigilant surveillance. These supervolcanoes are hidden because they lack the classic conical shape. Instead, they're vast, subsided basins detected through modern science. Geologists use seismic tomography to image underground magma, satellite interferometry to spot ground deformation, and geochemical analysis of gases to gauge activity. Recent discoveries, like potential calderas in the Pacific's Melanesian border plateau, show we're still uncovering these giants. While eruptions are rare, occurring every 10,000 to 100,000 years, their impacts are global. Ash veils the sun, causing crop failures and cooling climates for years. In unmasking these hidden supervolcanoes, we gain respect for Earth's dynamic geology. They're not ticking time bombs, but windows into our planet's past and future. Through international monitoring networks, we prepare for the unlikely but possible, ensuring humanity endures whatever fires from below. The next time you gaze at a calm lake or quiet valley, remember, beneath could lie a force that once shook the world.